Hello, so this is the last video for the first chapter, and this is about linearization. So it's transforming a relationship to linear form. So usually if you're doing an experiment and you're collecting data and you're plotting your dependent variable against your independent variable. So let's say your dependent variable is y and your independent variable is x. And usually it's not always the case that this relationship is linear. So it could be exponential, it could be quadratic. So we really don't know what the relationship is. And if it's, say, something like this, then these graphs are harder to work with. And we want to transform these relationships into a linear form because we are used to working with linear equations, y is equal to mx plus c. So we are going to try to convert these relationships into a linear form. And to do so, the process is called linearization, and basically we use natural logarithms. So you can take the natural log of both sides, or you can take the log base 10, because when we take the log of both sides, we can transform these relationships into a linear form. And when we transform these relationships into a linear form, then these are easier to work with because we can easily solve for a and b, or k and n in this case, or a or b in this case. So because we are used to working with linear equations, we'll do so. And again, remember that the natural log and the log base 10 are built in your calculator. So you can always easily perform the calculations if you take the log base 10 or log base e of both sides. So let's take the natural log of both sides, a e to the power bx. And we know that this is equal to ln a plus ln e to the power bx. And using the power law of logarithms, we know that this is actually bx times ln e. And remember, ln e is just 1. So we have ln y is equal to bx plus ln a. And now, if you plot the graph of ln y against x, you see that, hey, this, I can understand it as mx, and this is c. And if I say this is my capital Y, then I have something like this. I have a straight line graph because it's just y is equal to mx plus c. And the gradient, the slope of my straight line graph is just b, because that is multiplying my independent variable, b, and the y-intercept is just ln a. So that is something to remember. And in this case, if we take the natural log of both sides, then we have ln kx to the power n. And therefore ln y is equal to ln k plus ln x to the power n, using the laws of logarithms. And ln y is ln k plus n ln x. And therefore, ln y is equal to n ln x plus ln k. And therefore, if we plot the graph, so if I say this is capital Y, and this is capital M, and this is X, and this is C, then we again have a linear graph. And in this linear graph, we can see that if I plot ln Y against ln X, if I plot capital Y against capital X, then I again have a straight line graph. And the slope of this straight line graph, the rate of change, or the rise over run, is going to be n, or capital M, and the y-intercept is going to be ln k. C is your y-intercept, and m or n is going to be your slope, or your gradient, or your rise over run. So this is the idea behind linearization. So let's move on to solve some questions. Okay. So given that a and b are constants, use logarithms to change each of these nonlinear equations into the form y is equal to mx plus c. State what the variables x and y and the constants m and c represent. So let's just do, I won't do all of them. Let's just do a, b looks exactly the same, except because you have 10 here, you might want to take the natural log, log base 10. So let's do a, b, e, and f. I think that should be enough. Let's do a, b, e, and f, and I'll leave c, d, and g to you. So y is equal to e to the power ax plus b. Now, I can take the natural log. I can say ln y is equal to ln e to the power ax plus b. And ln y is equal to, using the power rule, I can say that ax plus b times ln e, right? And ln e is just 1. So ln y is ax plus b. So we are done, except our capital Y is going to be ln y, our capital X is just going to be x, and this is going to be m, and this is going to be c. So y is equal to mx plus c, where y is equal to ln y, m is equal to a, x is just equal to small x, and c is equal to b. So basically, that is how you obtain. And let me just check the answer for you is yes. So this is what they want. Y is just going to be ln y, x is just going to be x, m is going to be a, and c is going to be b. So this is how you change the relationship that you are given into a linear form, and an exponential relationship into a linear form. And these are easier to plot, these are easier to work with, especially when we need to graph the relationship and find values. Now b. Y is equal to 10ax minus b. We can take the natural log. We can also take log base 10. Both of them work. And because your calculator has the built-in natural base 10 log, then you can also work with log base 10, because then you end up getting the same answer. So let me take the log base 10 of y equal to log base 10, 10 to the power ax minus b. And we have log base 10y is equal to ax minus b log base 10 of 10, and that is just 1. So I have log base 10y is equal to ax minus b. And we're done. This is going to be your capital Y, a is going to be your m, this is going to be your x, and this is going to be your minus b is going to be your c. So this is exactly what the textbook has done. Y is log base 10y, x is x, a is m, and c is minus b. Yes. Now let's move on to part E. I have log x to the power a, y to the power b is equal to 8. And I can take the natural log of both sides. The natural log x to the power a, y to the power b is ln 8. And now I can use the rules. If I use the rule, I get ln a to the power x plus ln y to the power b is equal to ln 8. And using the laws, I have x, a ln x plus b ln y is equal to ln 8. And now I want to isolate. So I can write b ln y is equal to minus a ln x when I subtract a ln x from both sides. So this adds to 0, and I have minus ln x plus ln 8 on this side. And finally, I have ln y is equal to minus a over b ln x plus ln 8 over b. So now, this is going to be my capital Y. Minus a by b is going to be my m. This is going to be my x. And ln 8 divided by b is going to be my c. So this was question E. So this is, I think, exactly how they have done it in the textbook. So ln y is y. We have minus a over b is going to be your m. And c is going to be your ln 8 by b. And x is going to be your ln x. So yes. So this is the desired linear relationship. And now let's do f. F is very similar. Now I believe we have gotten used to solving these questions. So you take the natural log of both sides, x, a, y, is equal to ln b. And you have ln a plus y ln, ln x plus y ln a is equal to ln b. And now you have y ln a is equal to ln b, or minus ln x plus ln b. And finally, you have y is equal to minus 1 over ln a ln x plus ln b over ln a. So this is going to be your y, this is your m, this is your x, and this is your c. So this was part F, and I believe they have done it exactly in the same way. Well, they have done it in the opposite way. So I have plotted, my graph is y against ln x. So this is what I am plotting, but the textbook has plotted it in a different way. So let me just show you what the textbook has said. So the textbook actually has isolated from this step. It has said that, hey, ln x is equal to b minus y ln a plus ln b. So they have said that plus ln b. So they are plotting this as your y. And this is your, ln minus ln a. So minus ln a, y. So this is going to be plotted on your x-axis. This is going to be your slope, and this is going to be your constant. So they have done things in a slightly different way. But it's okay. As long as you have a relationship and you plot it and you know how to work with these, you're going to get the correct answer. So it doesn't matter whichever form you choose to write it in. Now let's move on. Now this is a more practical questions, and these skills are very, very helpful, especially when you start doing your practicals, when you're doing your experiments in physics and chemistry. Not all the relationships are linear. So that's why logarithms pop up a lot, because it's easier to plot these relationships, especially when you have ln or log involved. Because then your graph becomes linear. So the variables x and y satisfy the equation y is equal to ax to the power n, where a and n are constants. The graph of ln y against ln x is shown, and it passes through 2 points. So find the value of a and find the value of n correct to 2 significant figures. So let's just start by linearizing this. So we take the natural log of both sides, and I have ln a plus n ln x. So ln y is equal to n ln x plus ln a. Now if you think about it, ln y is going to be plotted on my y-axis. Ln x is going to be plotted on my x-axis, as it is in the diagram. I have ln x on my x-axis, ln y on my y-axis. And n is going to be your slope. And we can calculate this slope because we have been given 2 points. So n is just going to be your rise over run, or y2 minus y1 over x2 minus x1. So what is, you pick one. So this is, if you say this is x1, y1, this is going to be x2, y2. And if you do it the other way, it also works. So y2 is 3.22, this is y2, and y1 is 4.02. x2 is 1.83 minus x1 is 0.31. And when you do the calculation, 3.22 minus 4.02 divided by 1.83 minus 0.31, you get negative 0.526 to 3 significant figures. Actually, the textbook has quoted it to 2 significant figures, so let me just leave it at negative 0.53. So this is to 3 significant figures, this is to 2 significant figures. So that is the value of your n. So now, how do I know the value of my a? Well, I can use this relationship. I know that ln y is equal to n ln x plus ln a. So my ln a is going to be my ln y minus n ln x. And we have been given points. We have been given data points. So I can take any value. I can take 1 point. So let me take x2, y2. and I can substitute those in. So let me just do it here. Ln A is equal to ln Y. So this is, the Y values are going to be ln Y. So I can take 3.22 minus my N value. So I want to take a more accurate N value because I can estimate, I can round off towards the end. So let me just write the value that my calculator has given me, 0.5263157895. This is the more accurate N value, and then I have to take my X. So this value multiplied by my X, let me write X is, my ln X is 1.83. So when I solve this equation times 1.83, and then I want to subtract this from 3.22. So I get my ln A. So if you solve this equation, you get ln A is equal to 4.183157895. And therefore, A is going to be e to the power 4.183157895. And this gives me e to the power of my answer is 65.6. So 57. So let me just check how the textbook has rounded it off. They have rounded to two significant figures, that is 66. Okay, because they give, oh, I didn't see this, but okay. So two significant figures, it is 66. So this is how you approach these questions. So let's do question 3, and I'll leave question 4 and 5 to you as practice. I think in question 4, you have to take log base 10 and not the natural log because it makes your life easier. But I leave it for you to practice on your own. The variables x and y satisfy the equation this. Y is equal to k e to the power n x minus 2, where k and n are constants. The graph of ln y against x is a straight line passing through the points, this point and this point, as shown in the diagram. Find the value of k and the value of n to two significant figures. So it's the same question. It's the same type of question. So we start by linearizing. Ln y is going to be ln k e to the power n x minus 2. And this is equal to ln k plus ln e to the power n x minus 2. And this is equal to ln k plus n x minus 2 ln e. And ln e is just 1. So we have ln k plus nx minus 2n. So we have ln y is equal to nx plus ln k minus 2n. So this is going to be your y-intercept. This is plotted on your y-axis, this is plotted on your n-axis, this is your gradient. And we can calculate the gradient. N is just going to be y2 minus y1 over x2 minus x1. So take this to be your x2 y2, and this to be x1 y1. So y2 is 4.33 minus y1 is 1.84 divided by 7 minus 1. So that is just 6. So I have 4.33 minus 1.84 divided by 6. And to two significant figures, that is 0.42. But when I substitute into my equation, I usually want to work with more accurate values, and then I round off at the end. So ln y. So now I can just read off my graph. So let's take 4.33 as my ln y. So I'm taking y2. Remember, you don't want to substitute y inside the ln because your graph is ln y versus x. So if I had y versus x, then I would be substituting 4.33 inside the ln function. But now, for now, I just have to take ln y at face value. So 4.33 equal to 0.415. That is the more accurate value of x that I got, of n that I got. X plus ln k. So I know x. I can actually read x from my graph. So x is just 7. 7. And then I have plus ln k minus my n times 2 is going to give me 0.83. I have 2n. So now I can solve this. So this is going to be 4.33 plus 0.83 minus 0.415 times 7. that is going to give me ln k. So 4.33 plus 0.83 minus 0.415 times 7. So that is ln k is going to be 2.255. And therefore k is going to be e to the power 2.255 is equal to 9.53. And then to two significant figures, it's just going to be 9.5. So your answer for 3 is 0.42 and 9.5.